we were talking about a Venn diagram question. And so this is a typical Venn diagram question, which has lots of information. And just to remind you what a Venn diagram does is it allows us to do probability calculations with different groups. But I want us to do this question together. So question A, it says, draw a Venn diagram to illustrate the results of the survey. So I want you to have your pen and pencil with you. And there are 174 learners who were asked about their favorite sport. Okay. And then we have a whole bunch of information. Who wants to tell me what the very first step is? As I start going about doing a Venn diagram, I'd love to know, often getting going is really important. So I want to know some of the basics. You can put this in the chat or you can raise your hand. How am I going to start this question? So I'm given the survey and there's 174 students and they were asked what their favorite sport, and we're given a whole bunch of information. And then the first thing says draw a Venn diagram. So maybe what is that going to consist of? Who would like to raise their hand and give some input or an idea? So Nolwazi said, when drawing, start with the three-way intersections, or the one that the intersection of all three. So Nolwazi is suggesting that we should start with the 8 students who prefer all 3 sports: chess, swimming, and boxing. So basically the center of the intersection. Now, when we, Amanda, what we're doing is we're trying to draw a Venn diagram that represents all this information from the question. And the Venn diagram is going to help us understand how many people like different types of sports. And then we can go on to the probability part. Now, the second part is when we draw the Venn diagram, what we're going to do is we're going to draw a rectangle to represent the sample space. Okay, so how many people are going to be in the sample space? Let me know in the chat, how many people are going to fit inside the big rectangle? Okay, 174, exactly. Then the next step is, because there are some people who like all 3 sports, what I'm going to do is I'm going to start by drawing 3 circles to represent the people who like these 3 sports. And I'm going to label them chess. So, and another one was swimming. And then the other one was boxing. So inside each of these circles, for example, inside chess, there is going to be 90 people inside the chess circle. However, how many fit over here and how many fit over here, we don't know yet. And so I want you to take a moment and try, and Nolwazi helped us out by saying she was going to start by putting 8 people over here. So 8 people prefer all 3 sports. So that area is the intersection of all 3 circles. You can see it's inside all 3 circles. Take 2 minutes now and try and, let's say, or let's focus on one thing. Take this, 18 prefer swimming and boxing. What can you do with that information to help you? I want you to think about that. And how can you use the 18 prefer swimming and boxing? Where will swimming and boxing be? Swimming and boxing will be over here. And you know that bit is 18. So then the question is, what's going to be here in that region I put a question mark in? What's going to be in that region? Okay, so it's not going to be 18 by itself. It's going to be 18 minus 8 because it has to add up to 18 in total. So 18 people prefer swimming and boxing. Okay, and that means this total together is going to be 18. So this has to be 10. or 18 minus 8. So I've used that piece of information. Now we're going to do a next bit. Let's go to 27 prefer chess and boxing. Chess and boxing. Okay, chess and boxing, find the region. For me, chess and boxing is the yellow region I colored in here. This piece of information can help me get this. So what's that going to be? What's that bit that I've left there going to be? So I know 27 in total. So this is just going to be 27 minus 8, which gives me, oh, oops, come back. So this is going to be 19. Let me put that. Now, I want you to think about, so we've got that. 26 do not like any of these three sports. Who's going to tell me where this goes? I want to know, someone needs to come on the mic and tell me where does 26 do not like any of these sports. Where's that region going to be? Could you unmute Amakulani Lebo? I've just got too many windows open now.
Good afternoon.
Hello. Where do I go, Amakulani?
Outside of the circles, in the box, but outside the circle.
Aha. Is that what did you see the 26 appearing? Would you agree with that?
Yes, sir.
Perfect. Now, while I've got you, there's this X thing over here. Do you know about this? X prefer chess and swimming, but don't like boxing. What do I do with that X?
So, if I'm not mistaken, I think you'll say 94 minus X in S, the circle S, and then
Chess and swimming.
You'll say no.
So would you agree chess and swimming would be this pink region here? But the problem is they said chess and swimming, but not boxing. So can you see how you have to leave out the 8? It's chess and swimming, but not boxing. So it's just going to be over here. Does that make sense?
Yes, sir.
Perfect. Thank you so much for your help. So I've put give me a thumbs up if you understand how I put the X there. So X prefer chess and swimming, but don't like boxing. I want to see if I've done a good job explaining this. Do you understand how I put the X there? X prefer chess and swimming, but don't like boxing. That's why the X has to be by itself. Okay. I see Nikki has raised. Okay, cool. Now I want to know what is in the swimming. I'll give you a hint. What is this part over here going to be? So we've got swimming. We know 64% prefer swimming. Can you figure out what this region is going to be? I'll call this, yeah, I want to know what is that going to be? So we know that there are 64 people in the whole circle who prefer swimming, but I'm interested in just this region. So what do I need to do? It's going to be 64 minus all the other things, which is minus 8, minus 10, minus x, which is going to be 46 minus x. That's what I'll get for that. Using the same thinking, we'll call this, I want to know, what do we get for that region? And what do we get? Yeah, let's get that one next. The missing region for chess. The same thinking, except chess has 90 to start with. So we go 90 minus 19 minus 8 minus x, and we will get 63 minus x. Okay, almost done. What about this one? What do we get for that region? So we know 77 prefer boxing, but because these are all numbers, so 77 is the whole boxing circle, minus 19, minus 8, minus 10. And we should get 40. Yeah. 40. Oh, goodness, come back, circle. 40. Okay, so what have we learned here? We've learned that we start from the innermost intersection or whatever, that makes the most sense. And we work out with the information, crossing out as we go. We have done the first, and that would probably be worth about 4 or 5 marks at least in an exam. The second thing is now we have to answer the question, calculate the value of x. How are we going to find the value of x? What equation are we going to have to use? Who has an idea? Like, because we've got these regions, but there's things in terms of x, and we need to somehow find a value for this x. Who would like to raise their hand and offer a suggestion? So Bafano has said, add up everything and make it equal to 174. And you're exactly right, Bafano, because you know at the sample space, Komotsile said the same. So all you're going to do is you are going to just make sure you don't forget any of the regions. Plus 10 plus 40. So I think I've got everything. And when you add them all up, they are going to be equal to whatever the sample space is. Okay, now find me my value of x. I want you guys to find me my value of x. So you have to do a bit of algebra. The good news is you've got minus x and plus x. And then you just need to add up all these numbers, 19, 8, 10, 40, 26, 63. What does that give you as a number? To make sure I've got all the numbers here correct. Okay, so you should be ending up, watch out that you don't make any silly mistakes. You should be getting an answer of x is 12 in the final thing. So let's just have a look at that, 19, 8, and then 18. So all of these together. Yeah, so I get 200 and, why is this wrong? 26 was the right answer outside here. Okay, I'm just going to bring up the answer. So here is the correct answer. If you add up all these items, you should get 186. Maybe I've written it down. Maybe I've left something out here, but you should get 63 minus x is one of them, plus the x. Oh, did I leave the x out? No, I didn't. Plus x, plus 46 minus x, plus 19, plus 8, plus 10, plus 40. No, it's perfect. So you just have to watch out for any silly mistake. Where's the 26? Did I add the 26 in? Why is it leaving out the 26? 26 do not like any of these three sports. Okay. So in terms of this question, what they've done in terms of the answer is they've left out this first 26. And for some reason, they're leaving that out. I'm just going to move on for the moment. Oh, wait, no, it's the same thing because, okay, I'm going to move on for the moment because I don't want to cause too many problems. The basic ideas that I wanted to show you have been taken care of. Just give me a thumbs up if you understand the basic idea. And then I'm going to move on from this question for now. Just wait a moment or two. Okay, so I think this has got to do with the wording of the actual question. And so because of the 26 overall, I'll come back to this in a future lesson. But for now, let's move on to the main topic of today, which is the tree diagram. Okay, and then I would recommend having a look at the previous lesson for more practice on the Venn diagram. Okay, so what is a tree diagram? Let us consider a basic question like this. So when listing the combined outcomes of two or more activities, drawing a tree diagram is often the easiest method to use. And so in this situation, they've given us an example and they said, suppose a family has 3 children. There are many combinations of boys and girls that can make up these 3 children. So I want you to take a moment and draw a tree diagram as best you can, showing all the possible combinations for 3 children in a family. Okay, so go ahead now and do that. When you've done it, say done. And if you don't know how to do it, just give a thumbs down. So a very basic tree diagram.
Sorry, Mr. S.
Yeah.
I got kicked out. Can you please make me co-host?
I can, yeah. Let's have a look. Where are you there? And to make co-host. Okay, there we go.
Thanks, Mr. S.
Okay, so I see quite a few thumbs down. So when we draw a tree diagram, it's literally like a tree. So imagine the first option. If you're the first child, what are the options? There are boy and girl. So first child. Now that's if you start, but the second one, the second child, is also going to be a choice of boy or girl or boy or girl. So at the moment, how many possible options are there? There's BB, which is boy, boy. There's boy, girl. And what a tree diagram does is it looks like a tree, like breaking out into branches. Now, am I finished drawing my tree diagram? No, there is a third child. So that would look like another branch on the tree. And so it would look like that. And again, I just go BG, 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 BG. Okay, now, how many possible outcomes or how many possible outcomes are there for having 3 children based on what you see in this tree diagram? So I want to see in the chat, does this tree diagram help you understand how many different combinations there are, or how many different possibilities there are for having 3 children in terms of gender? And if you know, I want you to put that in the chat. So the one possibility is boy, boy, boy. So that's one possibility. You could also have boy, boy, girl. Now, this is assuming that, yeah. So how many different ways can you have 3 children if you're looking at this diagram here? It's going to be 8, right? There's 8 different possibilities. If you go down here, 1, 2, 3, 4, 5, 6, 7, 8. Now, something else that we do with the tree diagram is we generally write the probability of each of these branches on the branch. So if I ask you, what is the probability, if you are given, if there is going to be a child, and I say to you, what's the probability that it's going to be a boy? Do you know what the probability it's going to be a boy is? Can you give me a number in the chat? So assuming you only have 2 gender identities, it's going to be a half or 50%, right? So there's a half chance there, and there's a 50% chance it'll be a girl. Now, one of the things about tree diagrams is that if you have a second child, the probabilities are not going to change because they are independent events. They're not related to each other. So this would also be a half, and this would also be a half. In fact, every time you have a child, there's a 50% chance of each gender. So when we draw our tree diagram, this is sort of looks like a lot, but we generally draw it so that the probability of each branch is there. Okay, so how does this help us? So I've done my tree diagram. Now determine N of S, where S is the sample space. So for this tree diagram, there are 8 different possibilities. So N of S will be 8. And now we're going to work out the probability that all 3 children are girls. So that's our first question. Now, using the tree diagram, what's really, really nice is because each of these events, the first child, second child, and third child are independent, all we need to do is multiply along the branches and then add up each branch that is accurate. So I want to ask you, what is the probability that all 3 children are girls? If we look at my tree diagram, and I want to ask from the chat, what is the probability that all 3 children are girls? And how would we do it? So the only branch that has all 3 girls is the one I just put in green. And if you think about the probability, I haven't written down the identity for independent events, but what we need to do really is just multiply. The probability of girl, girl, girl is just a half times a half times a half, which is along these branches, which is going to be 1/8. Okay, now I want you to try and do, what is the probability that all 3 children are of the same gender? I want you to try and work out that question. And I'll give you a bit of time to do it by yourself and think logically about which of the branches satisfy this question. And then if there are multiple branches, what should you do? So what I'm going to do now is I'm going to highlight the 2 branches that show me children of the same gender. So if all 3 children are the same gender, the 2 branches that I think are relevant are BBB and GGG. Now, in order to get the probability that they're of the same gender, all that we're going to do is we're going to add together the probability of each branch. So it's going to be, the probability is just going to be 1/8 plus 1/8, which is going to be 2/8 or 1/4. So if you have a branch that is a favorable outcome, so in probability, we always come back to the original equation, Like, how many possible outcomes are there? In this case, there are 8. How many favorable outcomes are there? In this case, it would be 2 out of 8, right? Or 1 out of 4. But with a tree diagram, one of the nice things is you can just multiply along the branches and just add each branch. It's a bit of a shortcut. Okay, so now let us skip 3. Let's go to 4. Let me ask you this. What is the probability that one of the 3 children is a girl? So let's go to this one. Leave out the third one. I just want to see, can you do this one here? What's the probability that one of the 3 children is a girl? For this one, it may, yeah, think about how many branches are relevant is my tip. So I'm going to take away my yellow highlighter because the yellow highlighter was for all boys, and I'm not interested in that. I'm interested in where all the branches where one of the 3 children is a girl. So I actually need to get rid of this one too, because this actually doesn't fit either, because of the fact that there are 3 girls. So which ones only have 1 girl in the branch? For me, boy, girl, boy is the 1 branch, or boy, boy, girl. So both of those only have 1 girl in the family. Or you could also have girl, boy, boy. Is there anything else that we've missed? So one of the 3 children is a girl. So 1, 2, 3. I don't see any other options that show that only one of the children is a girl. So what is the final probability going to be for that one? Okay. So it's basically going to be for each branch that's correct, it would just be an 8th plus an 8th plus an 8th, which is 3 out of 8. Or you could just say only 3 of the 8 branches have are favorable, and so the answer would be 3 out of 8. Okay. So this was just the warm-up for tree. I know that it takes a while to get used to tree diagrams. And so what I want to do now is I want us to take a brief break where we stand up and stretch. And then we're going to come back after the break and we are going to try another example. But pop those cameras on and show me your best stretch while I close my window quickly. All right.
Come on, guys. Please join us in this stretch. We love to
Show me
see.
your happy faces, guys and girls. Let's do this. I'll put some light in the background so you can see me shaking it out. Let's do it. Your brain needs a break. And
Shout out to William, Nolwazi, Tato, Katleho.
Let's do it.
Awesome, guys.
Let's do it. Because you need to reset your brain a little bit. So do your favorite stretch and shake it out. There we go. Cool. Who is stretching the best? William's looking pretty good. Tatul, Nawazi. Okay, awesome. Okay, I hope you feel like you've had a little break, that your brain is reset a little bit. Let's do a brain break question. Here is your brain break question for today. What is the answer to this? You go to the doctor because you are ill and he prescribes you with 3 pills and tells you to take them every half hour. How long do the pills last you? Aha, keep those answers coming. Okay, so I'm going to show you how I take my pills. So I take my first pill now, and then I wait half an hour and I take another pill. And then how many pills have I got left? That's my hint for you. So watch out, you're being caught out, guys. So think about, you take your first pill. Aha, nobosetu, there we go. It's 1 hour because you take your first pill now, then you wait 30 minutes, then you take another one. So that was 30 minutes. And then you take another pill, and then that's going to be 30 minutes. So how long is the total time going to be? It's going to be just 1 hour. All right. So watch out. My brain breaks are always a little bit sneaky. And so you have to, cool. All right. Cool. Let's get back to the tree diagram questions. So if we go on to, let's do this as a multiple choice thing together now. 2 dice are thrown together. Okay, 2 dice are thrown together, and I'll show you how we represent that with a tree diagram. And what we're interested in for this question is you need to find the probability that one number is even and the other number is odd. So whenever you throw a dice, okay, so let's say dice 1 and dice 2. So here's the first one. There's only 2 possibilities. There's going to be even, so 2, 4, and 6, or odd. And then if you throw a second dice, you would have a second branch on your tree diagram. So you would have E, O, E, O. Now, I'm not going to write the probabilities on the diagram yet because that would spoil the question. But see if you can figure out what answer you think it is. A, B, C, or D. So that would just be a half. So how many branches? So the event question is basically there's 4 different possible outcomes. And you can see that the ones that I'm interested in are going to be one number is even, the other number is odd. It doesn't matter what order it happens. So 2 of these branches are going to be relevant. And so the correct answer, so one of the branch, the probability of one of the branches is just going to be a half times a half, which is a quarter. But because you've got 2 branches, the final answer would just be a quarter plus a quarter, which is 2/4 or a half. And so the correct answer is going to be C. Another way of seeing that is just to see that only 2 of the 4 branches are favorable for this particular question. Okay, let's try a slightly harder one. So what we're going to do in this next one is we are going to make it sort of a little bit more interesting. So let's think through this. Teddy has 2 pairs of black shoes and 3 pairs of brown shoes. He also has 3 pairs of red socks, 4 pairs of brown socks, and 6 pairs of black socks. I just want you to first, before we even answer the question, see if you can draw the tree diagram for this. So in this question, there's two main ideas. There's shoes and there's socks. See if you can draw a a tree diagram. And once you've drawn the diagram, just say done in the chat. And then you can start the question. But I just want to see like, see if you can take a moment and see if you can draw the tree diagram. What would your tree diagram look like before we even try to answer the question? And then just say done when you've drawn your tree diagram. Three pairs, four pairs, red. So I have black and brown, and then I have red and brown and black. So I'm going to call this BL for black and BR for brown. And that's going to be shoes. And then I think these need to have three options because there are three different colors of things, of socks. So we have red, we'll go brown, and what was the other one? It's black. And then here it would be red, brown, and black. Give me a thumbs up if you understand my tree diagram so far. Now, I haven't actually put any probabilities on yet, but I just want to see if you understand the way I've drawn this diagram. Okay. Now, if you understand how I've drawn it, I want you to try and put the probabilities on each of the branches. So while you're doing that, I'm going to explain it again, but I want you to take a moment to try and think about what is the probability when you start this. You've got two decisions to make. The one is shoes, which is going to be basically this choice over here. So those are the shoes choice, black and brown. And then the second choice is going to be about the socks. And there's three choices for socks, which is red, brown, or black. I want you to think about when you start this, I'll give you a little hint. The chances of choosing a black shoes, how many different types of shoes? There's 5. So this would be 2 out of 5. So that's my little hint. See if you can fill in the other branches on this. So in terms of shoes, there are 5 pairs of shoes. 2 of them are black. And so we put 2 out of 5 on this branch. And then the question is, what do we put on this branch over here? And then also, can you think about what goes on each of these branches? And then when you're done, just put done in the chat. And then we'll try and answer the question. So the 11 socks, and then there's 5 shoes. I think it's quite helpful to have that information. So how many of them are red? So that would be 3 out of 11. Brown is 4 out of 11. And then black is 6 out of 11. And this would be 3, 4, 6. Okay. So now, I know that we're going to have to repeat this a couple of times. Did I make a mistake? Let's see. The Sunder, whereabouts? So 2 out of 5, 3 out of 5. 3 pairs of red, 4 pairs of brown, and 6 pairs. So 3 plus 4 is 7, plus 6 is 13. Yeah, exactly. Apologies. There we go. So this should be out of 13. Thank you, everyone. Well spotted. 13, 13, 13, 13. Okay, now, I'm so impressed by my class. Very alert, everyone. Fantastic. Okay, now, here's the question. It says, if Teddy chooses a pair of shoes at random and a pair of socks at random, what is the probability that he chooses shoes and socks of the same color? And using the thinking that we've used so far in the lesson, I want you to see, can you figure out what you think the right answer is, A, B, C, or D? So which of the branches do you think is a favorable outcome for us? So we're asking about when shoes and socks are the same color. And so for me, it feels like this branch over here is the only branch on the top that can have the same color shoe and socks. And then the other one is going to be brown and brown. So now the question is, how do I get the probability of either of those two happening? And I need to multiply along each branch. So the top branch would be that one. But now because I have 2 branches, I have to add them together. So this one will be 3 over 5 times 4 over 13. So I'm multiplying. And so what answer will I get? Well, in fact, I've actually got the answer down here, so I can just pull it up for you. Let me do that. So you should get 24 over 65. That is the correct answer, or B. Okay, so these questions do actually take quite a bit of working out, but the main idea is that you draw your tree first, you label it properly, and then what you do is you put the probabilities on each branch, and then you ask yourself how many of the branches are a favorable outcome for the question that's being asked. Okay. Give me a quick bit of feedback. Thumbs up if you feel like you're broadly following. Thumbs down if you're feeling very lost. Just want to get a feel for how the class is doing. Okay, be honest. We do want to see, because I just want to know how fast, and also if we can squeeze in one more question here. I can zoom in on the solution a little bit, so those who want to take a screenshot can do so. I think basically the tree diagram is probably the one that is most helpful. Okay, let's try and squeeze in one more question before today ends, because I know, yeah, okay. Let's do, oh, actually, is it going to be time? Okay, we're not going to finish this question today, but let's just try and see if we can do some of it. So here is your question. A bag contains the following marbles. A marble is drawn and then it's put back, and then another marble is drawn. Draw a tree diagram to represent this information. So all I want you to do, we're not going to answer this question yet. You're just going to draw a tree diagram to show me the situation. And we call this drawing with replacement. And once you've drawn the tree diagram, just say done. And then I can see that you And then we'll carry on in the next lesson with this tree diagram stuff. So I think my diagram actually has to have 3 choices each time, because whenever I'm drawing, I could have red, blue, or white, and then red, blue, or white. So I'm just going to go like that. Rosario. So now, can you figure out what the probability on each branch is going to be? So this is the tree. Now, in order to do the probabilities, adding these up correctly is probably a good start. So 6 plus 5 plus 11, I get 20. So then ask yourself, what are the branches of this tree going to be? So this is going to be, the blue one is going to be 6 out of 20. The red one is going to be 5 out of 20. And this one over here is going to be 9 out of 20. And luckily, because you are putting them back, the probabilities are going to stay the same. So, I mean, it's not, if you had taken something out and not put it back, that would have been a different story. But really, I'm just repeating myself on these branches. Okay, now, I said we weren't going to do this, but I've gone a bit fast, and there is probably time. So work out the probability that both marbles I draw are white. I want everyone to try, we'll finish with that. What is the probability that you draw a marble and it's white, and then you draw a second marble after replacing it and it's white again? Which branch of the tree am I looking for, and how would I work out that outcome? So the tree diagram is summarizing the choice making. The first choices are blue, red, and white, and that is the first set of choices. The second set of choices are here. This is for, but the numbers don't change because I put the original marble back in the bag. I want to know which branch represents the outcome I'm looking for. And it looks to me like I want white on the first draw and white on the second draw. So now it becomes, how do I work out that probability? And one of the main ideas from today is that if I have a tree diagram with independent events, all I need to do is multiply along the branches. If there are multiple branches, I add them. But in this case, there's only one branch. And so my answer is just going to be that, which is 81 over 400, or in decimal, it would be, if I put it into percentage, it would be 20.25%. Yeah, that's it. Okay, now I think I probably went a little fast today. So what I want to say to you is, even if you feel a bit unsure, remember we are going to do another lesson on this on Wednesday, where we go over probability questions again like this, and where just the process of using a tree diagram to keep track of the question is going to feel a lot more natural. So that is my promise to you. Lebo, if you could put the link to the poll in the chat, that would be awesome. And are there any final questions before we wrap up today? Anything you want to clarify or check in on, or, well, yeah. Who has a question that they would like to ask? Lusanda, let me unmute you. Yeah. Hi, Lusanda.
Hello, sir.
How's it going?
I'm good. So I wanted to ask, every time when you calculate the probability, you always multiply.
Okay. It depends on the question. If you're dealing with Venn diagram questions, then often you'll be looking at the different regions and say, like, how many possible students are there, and then what region is represented. But if you're dealing with independent events, or even dependent events that have this choosing, basically when you're choosing things from like a box or from a situation where you're drawing a tree diagram, then you'll be multiplying to get your probabilities. And we're using something called the independent events identity, which I'll talk about a little bit more in the next lesson. Okay.
Okay, thank you, sir.
Cool. Okay. Any final questions before we wrap this up? I see somebody else was wanting to ask a question. Pop it up there and we can get going.
Good evening, sir.
Hey.
So I just wanted to quickly ask, why were the branches expanded? Because I think I made a mistake of just drawing the tree diagrams of one branch, of one blue, red, and white. So I wanted to ask, why was it further expanded?
Okay, so if you think about, this has got to do with the event. The first event is drawing the first ball and then the second ball. Whenever you have a compound event like that, you need to multiply the probability of each event. So there's an identity which says the probability of A and B is the probability of A times the probability of B. And that's for independent events. And so we're using that identity to calculate the probability of drawing white on the first one and white on the second one. So it's not just one part, there's two parts. Does that kind of make sense?
Yes, sir. Thank you.
So we're trying to incorporate the fact that we're drawing a second ball after drawing the first.
Oh, okay. Thank you, sir.
Okay.